Hello everyone. So the next topic is heating effect of electric current. So we know that a battery or a cell is a source of electrical energy. The chemical energy within the cell generates the potential difference between its two terminals that sets the electrons in motion to flow the current through the resistor or the system of resistors which is connected to a battery. And we have also seen what is current, what is the source, the chemical energy, right? For example, in battery we are having load of chemicals, right, like ammonium chloride, cadmium. So all these chemicals has to spend its energy so that the electrons will move, and the electrons will move, thus resulting in the current. So you might have the question like, where does this energy go? So a part of the source energy in maintaining the current may be consumed into useful work, like in rotating the blades of the fan. Reset of the source may be expended in heating the temperature of the gadget. We often observe in our day-to-day life. For example, an electric fan becomes very warm if you continuously use for a longer time. So on the other hand, if the electric circuit is perceivably purely resistive, that is a configuration of resistors only connected in a battery, the source energy continually gets dissipated entirely in the form of heat. This is known as heating effect of electric current. This effect is utilized in devices such as electric heater, electric iron, and we are seeing this heating effect of electric current in our day-to-day life as well. So you have to consider a situation of current flowing through a resistor of resistance R. Let the potential difference be V, let time be T, and the charge flowing through the conductor be Q. So the work done in moving the charge Q through the potential difference V is VQ. So therefore the source must supply energy equal VQ in time T. So hence the power input to the circuit will be equal to P is equal to V into Q divided by T, which can be represented as power is equal to VI. So or the energy supplied to the circuit by the source in time T is VIT. So what happens to this energy expended by the source? This energy gets dissipated in the resistor as heat energy. So thus for a steady current I, the amount of heat produced in time T will be equal to VIT. So applying Ohm's law, we will be getting the answer as H is equal to I square RT. Okay, so this is known as Joule's law of heating. This law implies that the heat produced in a resistor is directly proportional to the square of the current for the given resistance, and it is directly proportional to the resistance for the given current, and it is directly proportional to the current for which the current flows through the resistor. In practical situations, we can when an electric appliance is connected to a known voltage, it is after the current through it using the relation I is equal to V by R. So there are various practical applications of electric current as well. The generation of heat in a conductor is an inevitable consequence of electric current. In many cases, it is undesirable as it converts useful electrical energy into heat. In electrical circuits, the unavoidable heating can increase the temperature of the components and alter their properties as well. However, heating effect of electric current has many useful applications. The electric laundry iron, electric toaster, electric oven, electric kettle, electric heater, some of the familiar devices based on Joule's heating. The electric heating is also used to produce light as in the electric bulb. Here the filament must retain as much of the heat generated as it possible so that it is very hot and emits light. It must not melt at high temperature. A strong metal and high melting point such as tungsten is used for making bulb filaments. The filament should be thermally isolated as much as possible using insulating support. The bulbs are usually filled with chemically inactive nitrogen and argon gases to prolong the life of the filament. So most of the power consumed by the filament appears as heat, but a small amount will be in the form of light radiated. Another example of Joule's heating is the fuse used in electric circuits. It protects circuits and appliances by stopping the flow of high current. The fuse is placed in series with the device. It consists of a piece of wire made up of wire alloy, appropriate melting point, for example aluminium, copper, iron, lead, etc. So if the current is larger than the specified value flows through the current, the temperature of the fuse wire increases. This melts the fuse wire, which breaks the circuit. The fuse wire is usually engaged with a cartridge of porcelain, and the fuses may rated as 1 ampere, 2 ampere, 3 ampere, for an electric iron which consumes 1 kilowatt. So electric power when operated at 220 volts, current 4.54 ampere will flow through the circuit. Okay, so in this case 5 ampere fuse must be used. Okay, so this is all about the topic.